Hello, these are the exercises for section 3.4 on confidence intervals. So the first exercise is on confidence interval in the media. So they'll give you a website, and at this website, you see this 2014 Gallup study that reported 19% as the sample proportion of Americans who trusted television news sources a great deal or quite a lot, with a margin of error of 4%. What is this confidence interval? So the first thing that we should think about is that our confidence intervals are a point estimate plus or minus a margin of error. So our first point estimate in this case is going to be my sample proportion, my p hat. Then we'll have plus or minus my margin of error. Okay, so in this case, my sample proportion is 19%, plus or minus a margin of error that is given to me as 4%. Okay, so this is one way that you can write the confidence interval. Okay, what this is saying here is that there's actually two different expressions. One is 19% minus 4%, which is 15%, or it's 19% plus 4%, which is 23%. And if you look at this, then you can also write the interval as 15% to 23%. And that would also be another way to write the confidence interval. Okay. Oftentimes, they don't write it to you as percentages, they give it to you as a proportion. So you can write this as 0.19 plus or minus 0.04. Also, because that'll be as a percentage changed into a decimal, or you can write it as 0.15 to 0.23. And that would also be a fine way to write this interval. Okay, what's an appropriate interpretation? So with 95 confidence, the interval, and I'm going to use this one, 15% to 23%, contains the true proportion of Americans who trusted television news sources a great deal or quite a lot. And I wanted to point out that when you are writing these confidence intervals in context, you should go back to the problem, because as you can see right here, proportion of Americans who trusted television news sources a great deal or quite a lot is what I wrote almost exactly right here. So we're trying to figure out an estimate for that, and so we went through and we found an estimate with a point estimate and a margin of error. That's my confidence interval. The next exercise says to estimate the proportion of students at a university who smoke, a random sample of 200 students was obtained. Of the 200 students, 40 smoked, which resulted in a 90% confidence interval of 0.153 to 0.247. Okay, so we're going to actually do this question in a number of different ways. First, we're going to think about what is the point estimate and the margin of error. So our point estimate, remember from above, was my p hat. Oops. Okay, your p hat, your sample proportion is x over n. X is the number that you are looking at with the characteristic that we are interested in, characteristic over the sample size. Okay, so here we are interested in how many students smoked, and 40 of them smoked out of my sample of 200. So that is going to give me 0.2. So my point estimate is my sample proportion, which is going to be 0.2. Okay, so okay, now what we have is we have our smack dab the middle of our confidence interval, and we have to go through and add the margin of error or subtract the margin of error to get our upper and lower limits of my confidence interval, which I actually was given. I was given them as 0.153 and 0.247. Okay, so if I want to find the margin of error, I want to find the distance between the center, this point estimate, and either of these limits. Okay, so what I can do is I can be like, oh, well, my margin of error is going to be 0.247 minus 0.2 is 0.047. And that would be my margin of error. Okay, I also could have done this as doing 0.2 minus 0.153, and that would give me the exact same thing also, because this distance is the same margin of error as that distance is, because when we go through and we do our confidence interval, remember it's our point estimate plus or minus our margin of error. So you have to add and subtract the exact same margin of error, right? Okay, so let's go through and do method 2. Okay, so we were actually given the number in our sample and the number that had the characteristic of interest. However, what if I was giving you, I gave you just this interval? So all I gave you was this lower limit of 0.153 and this upper limit of 0.247. Could I then still give you the point estimate and the margin of error? Let's think of this for a little bit. So we know the point estimate is going to be smack dab in the middle of my interval, right? So I got to think about how can I find a number that's exactly in the middle of my lower limit and my upper limit. Okay, so there's a couple ways to do this. One way that students oftentimes come up with really quickly is, well, you find the distance between those two numbers and subtract and divide it in half, and that's this distance right here. So let's go through and find the distance between these two numbers. So we have 0.2, so my distance D, 0.247 minus 0.153, and this gives me 0.094. So I'm saying that this entire distance is 0.094, but I only want half of it. So half of that distance is going to be 0.094 divided by 2, which gives me my 0.047. So that's giving me this distance right there, which we know is going to be my margin of error. So you can see my margin of error is given right there as 0.047. So we have our margin of error, but which is the same as we got before. But now we have to go through and figure out how would we find our point estimate. Okay. Well, we know that this point estimate is exactly 0.047 away from this lower limit of the confidence interval. So we just go through and do 0.153 and add that to 0.047, and you get 0.2. That's your point estimate. Okay. There's a couple other ways that you can go about doing this, but those are going to be pretty universally used, either method 1 or method 2, depending on what information you're given. Okay. So now we want to go through and we want to write an appropriate interpretation of this confidence interval. Okay. And so we're going to say, so my interpretation is with 90% confidence, the interval, and I'm going to go through and I'm going to do 0.2 plus or minus 0.047 contains the true proportion and what are we looking for here? So we're looking for the proportion of students at the university who smoke. Okay, so I'm going to go through and I'm going to see if I can give myself a little bit more room, and I'm going to write that the true proportion of university students who smoked. Okay, so somewhere between 15.3% and 24.7% is the proportion of students at the whole university that smoked. And that's my confidence interval, so I only have a 90% confidence that that is going to actually contain my proportion, but it's a good estimate. Okay, and that's what confidence intervals are doing. They're estimating the parameter. Okay, let's go do that. So let's go through and look at this last exercise. Okay, so I encourage you, if you haven't done this already, to take a moment and read through this problem and try to figure out which interpretation you think is the correct interpretation. Okay, we're going to go through right now together. In late June, Survey USA asked 600 Kansas residents whether they plan to set off fireworks on July 4th. Their responses resulted in a 99% confidence interval of 0.501 to 0.612. Which of the following is the correct interpretation of the confidence interval? Okay, so hopefully as you tried it on your own, you got that D is the correct interpretation. So we are 99% confident that the interval between 0.501 and 0.612 captures the proportion of all Kansas residents who will set off fireworks on July 4th. Let's go through for a moment and see how the other four options were not correct. So here on A, 99% of Kansas residents will set off between 501 and 612 fireworks on July 4th. So this is, first of all, we have here a like a proportion, percentage. So it's, when we do confidence interval, we're not doing a proportion. We're not saying that it's a proportion of all residents. That's not what we're saying. We're saying with this amount of confidence, we think the proportion is actually in the interval. Okay. So that one is not it. So it's not a proportion, it's a confidence level of this estimate of a proportion. Okay. Then the second option, there is a 99% probability that the proportion of Kansas residents who will set off fireworks on July 4th is between 0.501 and 0.612. One of the big differences between here is that here we are saying that it's a probability, when really it's a confidence that we have. So we don't have a probability, we have a confidence, so that can't be the answer either on part B. On part C, let's look at this. So we are 99% confident that the interval between 0.501 and 0.612 captures the proportion of Kansas residents in the sample who were set fireworks off on July 4th. So let's think about what's the difference between C and D. Okay, so in C, we have this idea that we're estimating the sample. Sample proportion, where here we're doing the proportion of all Kansas residents. So when we go through and do our confidence intervals, we use our sample proportion as our point estimate. So our sample proportion will always be in our confidence interval because we use it to form our confidence interval. We are using the confidence interval to estimate the population parameter. So we're estimating the population parameter, so we have to go through and give our confidence interval that's containing our population parameter. In this case, is a population proportion. Okay, so we are not a sample that we're estimating. It's not a sample proportion that we're estimating. We are estimating a population parameter. And on part E, Kansas residents will set off fireworks on July 4th between 50.1% and 61.2% of the time. Okay, so you can give this confidence interval as a percentage. So I could have said we are 99% that the confidence interval between 50.1% and 61.2% captures the proportion of all Kansas residents who will set off fireworks on July 4th, which is basically doing D, but just changing these proportions into actual percentages. And that would be totally correct. However, here, this is saying that we're saying like a proportion, so it's like not a proportion of residents so this is a proportion. So here we're looking at a proportion at time. That they're doing this fireworks. So it's not a proportion at time. And remember, there's not even any confidence indicated on this. And so we are looking at a proportion of residents, not a proportion of time. Plus, we don't even have the confidence interval indicated in this interpretation. So it can't be right. Okay. So thank you. Have a good day.